this language of mathematics. Grammar. In mathematics, there's no past tense, there's no future tense. There's only present tense. You guys with me? Present tense. Present tense. Only. Present tense only. No past tense, no future tense. Now, in mathematics, we have two kinds of statements. Two kinds of statements and two kinds of statements only. Okay? Two kinds of statements only. You will see this when you write programming, when you write programs. Any language you use, there are only two kinds of statement. One kind of statement is just a statement. Sometimes they call it assignment. Okay, so the first kind is called a statement. The second kind is called an if statement. If statement. There are only two kinds of statement. Have you guys heard about it? How do we make the statement? And of course, when we talk about statement, the statement can be true or false, right? So any statement can be true or false. For example, I make a statement, right? It never rains in LA. Is that true or false?
False.
Why? How do you prove me false?
There's certain seasons where it rains.
That's right. You only have to tell me there's one day it rained in LA. Then I'm proved false. So now this comes to how do we judge a statement true or statement false? Okay, for example, if true statement, a true statement is a statement that's true forever, always true. False once, false. So in mathematics, there's no statement it can be true, can be false at the same time. You cannot say, oh, there's certain statement. It's true sometime, it's true it's false some other time. If it's false once, it's false. So the criteria of judging mathematical truths is very, very simple. If it is true, it is always true. If it is ever false, it is false. Truth, that's a statement. So let's look at some mathematical statement. Let's look at some mathematical statement. Okay, do you guys have any examples? I'm going to give you some examples, right? So now, have you guys seen this? What is this? I believe a lot of you are familiar with this form, right?
It has to do with the slope.
It has to do with the slope. And what does this do?
the formula to find the slope?
Right. This is actually, it is about, it's a description. It's a description of a straight line. It's a description of a straight line. Yeah. And you're right. M represents the slope. And what about B?
The y-intercept?
Excellent. You can see that mathematic statement is a highly shorthanded, right? There's a lot of shorthand notation. Every symbol represents something. Every symbol has a meaning. Now, what does this statement say?
This is a
Go ahead.
this is a line. This is a straight line with a y-intercept of b and a slope of m.
Wonderful. Very good. Now I want you guys to see this from a different perspective. Now I want you to see it from a different perspective. What is that perspective? There's an X here. Okay, because once we assign the value to X, right? We call plugging the numbers. And then we're going to follow a rule. So this is a description of the rule that the input has to follow. You give me the input, I'm going to take the input, multiply the slope, and add the y-intercept. And this equal sign, what does the equal sign mean? The equal sign is meaning is assigned to or equal, right? Is assigned to. So this is like an assignment. This is like assignment. So you give me the input and I follow this formula, then I produce a number as a consequence. And this consequence is going to be assigned to a number called y. And so X, I call it input, and Y is our output. So this statement is a description of a rule. Okay, so this is a description of a rule. From input to produce output. Are you guys with me? So this is another perspective. This is the perspective. This rule, we're gonna have a name for it. We're gonna have a name for it. It's called a function. Have you guys heard the word function? Trig function, sine, cosine, tangent, cotangent, arcsine, logarithm, natural logarithm, you know, all of these things you have learned before in your algebra classes, no matter which class you attended. You either talk about statement as a rule, a description of a rule, or you're stating a fact, which may be true or false, which may be true or false. Okay, so let me give you another example. So you can see that these are all in the category of a statement. Okay, this statement is description of a rule. Description of rule. Is it true or false? This is true to describe a line. So to describe a straight line. It would not be true if we describe a curve, right? It would not be true if we describe a say a parabola. Okay, so let me give you another one. Ax squared plus bx plus c. provided A is not 0. This one, once again, is a description of a rule. Okay, is a description of a rule. Let's see how this rule works. If we go by this perspective, you give me an input, and the rule says, take this input, okay, multiply itself, and that's x squared, right? We take that input, and then x squared multiplied by a. Then I'm going to take my input and multiply by b. And then I'm going to add a c. And then I'm going to produce an output. So this expression, once again, is being described as what? It's a rule. Okay? And this rule is, so once again, we have a description of a rule. I just mentioned the function, right? So we say, oh, let's introduce the word of function. So what is a function? I want you guys to turn to your second page of your notes. The second page of your notes. There's a definition of function. And I want you guys to write it down on your notebook. If you have flashcard, I wish you guys to write it down on your flashcard. Function. This entire semester, our theme of this course is the function. We're going to talk about the different aspects of function and how many functions out there and how many functions we can create. You will find that the number of functions we can create is infinite. But all of these functions, the description of these functions will be condensed in this one sentence. So this one sentence is powerful. This one sentence is powerful. It covers all of those functions. And we're going to study the method of study these functions. Okay, so now I want you guys to look at the first table, which is on page number 5. Okay, on page number 5. Do you see that? Do you see that table? I only have listed 22 functions. And we're going to build on these functions infinite many more. Some of these functions might be used in the computer game you played. Okay? Your favorite characters' movement may be determined by these functions. And or combination of different functions. All right? So now let's look at the definition of the function. It says a function is a rule. How many rules we just covered? There's one rule here, and there's another rule here. For each rule, their input, their output, input, output. I'm taking this approach because this will lay the foundation for you guys, even when you're doing computer science. Some of you might be learning, you guys are all STEM major, right? So you're gonna have to do some coding somewhere down the road. And this will be the same idea. Computer science, computer programming is directly application of mathematics, which you have assignment, statement, or if statement. We're going to talk about if statement. Okay, so let's look at the rule. this rule, right? You have an input, you have an output. So, and this is the function, we call it f of x. So I'm introducing this notation for you, this notation. This notation, okay, basically says, hey, this is the input, and apply the input, apply the rule, I get output. And this is the shorthand notation for function. Input, the whole is output. I want you guys to get used to this notation because we're going to use this throughout the semester. We're going to use this throughout the semester. So that's the first kind of statement, as you know, two kind of statement, right? One is just a statement, okay? And the second kind of statement, we're going to address the second kind of statement, okay? And the first kind, if you guys have learned about it in algebra classes, have you learned the word called expression? Have you learned the word expression? Have you? I have overlooked the, yeah, a lot of you have said yes, right? The word expression is actually function, right? It's actually function. Now, let's look at the second kind of statement. If statement. What are if statement in mathematics? They are equations. You only have two kinds of stuff to deal with in mathematics. One is a statement, the other kind is if statement. So that's the grammar of mathematics. No past tenses, no future tenses. And then we read mathematics. How do we read mathematics? When we read mathematics, we read it from top to bottom, left to right. Top to bottom, left to right. Okay, so these are the basic grammar of mathematics. Okay, so for example, okay, what an if statement? Suppose I have 2x plus 5 equals to 3. What do you call this? Equation. You call this equation, right? Have you guys seen this before? Of course you've seen it. What does it say? This is an if statement. It says 2 times an unknown number okay? It says if 2 times an unknown number plus 5 is 3. What could the unknown number be? What could x be? So you can see mathematical language is full of shorthand notation, right? But once again, you only have two kind of structures of sentences. One is a statement, the other one is if statement. And you have no future tense, no past tense, only present tense. Doesn't that make grammar simpler? And that's the whole thing we work through this semester. And we're going to be focused on these concepts, the two kinds of statements and function. So let's see what are the tools we have. Do you guys have your flashcard with you? We're going to get back to our first page. This is the essential of this course. Okay, so we covered the two kinds of statements, and let's look at the mathematical principles. How many do we have? We have 6. We have 6. These are the 6 principles we're going to use throughout the semester and even beyond. So let's look at the first statement. If you have a flashcard, so please, we start filling up the flashcards. Are you guys ready? What is the first? What's the flashcards? Let me give you an example of a flashcard. Hold on. You guys see that? You guys see that? Okay. It's just a piece of paper. It could be lined, it could not be lined, it may not be lined. I wish you guys to have these cards with you. Okay? The first card. I call these principles as self-evident facts about numbers. So we're gonna go over these, okay? Self-evident facts. I wish to, go over these and you tell me whether these are qualified as a self-evident facts. The first one, any number times 1 stay the same. Do you agree? Any number times 1 stay the same.
Yeah.
Is that self-evident?
Yes.
Any number times 1 stay the same. And what is a mathematical expression? This is a statement. This is a statement. Okay, this is a statement. Is this statement true or false? This statement says any number represented by A multiplied by 1 is the same as the number itself. Shorthand notation. So obvious, isn't it? Who does not agree that this is self-evident? And yet we use it in mathematics. Does anyone recall the places we use it? Suppose we have 5/10. Can we reduce it?
Yes.
How would you reduce it?
Divide by 5 and it would be 1/2.
That's right. Okay. So 5 times 2 is 10. 5/5 is 1, right? So anything times 1 is the same as a number. So we have used this properties here. Any number times 1 stay the same. Another situation. Okay. Suppose we want to rationalize √2 minus 1. Okay, if you don't remember this, just follow, okay? There's exercise in the notepad package. I would say basic 35, something like that. We're gonna utilize this tool to multiply by 1. We're gonna multiply by 1. Anything times 1 stay the same, so the equal sign is justified. So, but we're gonna make 1 very special. The 1 of our choice is gonna be root 2 plus 1. Plus 1. Some of you may say, oh, I learned this technique somewhere before. Guess what? You're going to get to use it in calculus class as well. Yes? So that's the first principle. Okay? Principle number 2. Any number at 0 stay the same. Can we say that's self-evident truth? Absolutely, I agree with you. That's a self-evident truth. In shorthand notation is that any number plus 0 is the same as the number. You see, we use the shorthand notation. So what I want you guys to do is that when you see mathematical symbols, don't just read it as the face value. Make sentences so that it makes sense to us. Okay? Sometimes some people was, I remember at the discussion, someone asked me, what's my first roadblock, right? Let's go back to the chat. Someone tell me that moment. Could you please re-explain how homework will work? Oh, I haven't, I will explain the homework, okay? Back earlier, someone was asking that question. I used to sneak and take my parents' car at night, taught myself somewhat how to drive. Oh my God, you're so smart. I remember that story. The 2 underage minor, the sister was 8 or something. She drive her sister. They want to drive from Oregon. They want to drive to California to see the dolphins. I hope you're safe. Okay. Someone asked me, what are my first roadblocks?
Yeah, that was me.
That was you.
Uh-huh.
When did you hit your first roadblocks in math? You know, besides hitting that big roadblocks in my life, learning mathematics, I hit some minor ones too. Okay, so that's how I can relate to you guys. Okay, it's my past experience. Because I'm not so smart, because I'm just so dumb, I learned mathematics and I can relate to a lot of the misunderstandings our students could have, right? You look at all these symbols, right? We look at all these symbols. What does it mean? Guess what? One day, I start to pay attention to this, to what the teacher says. Not just reading out a symbol, not just say, oh, a plus 0 equals to 0 equals to a. No, you don't read it that way. You read it in its meaning. The meaning is that any number at 0 stay the same. Who doesn't agree with you? Who doesn't agree with that statement? Such self-evident fact. What is it? What is it useful for? Yes, it's going to be useful for us. It's going to be useful for us. One of the situations we're going to use is to complete a square. Okay, we're going to address this in quadratic, everything quadratic. For example, if I have x squared minus 2x, right? We know that this is a rule, right? This is a rule. I'm going to make a completing square. I'm going to make a perfect square without changing the rule. We want to make a perfect square without changing the rule. What do? We know this is the rule, right? So what does it mean? This is the rule. I give you the input. Going through this rule, I'm going to produce an output. I'm going to produce the output. That's the rule. This rule says, right? This rule says you cannot change the rule. We cannot change the rule. What does that mean? So I'm going to take this expression, I'm going to take this rule, okay? Without changing the rule, I'm going to make a perfect square. Without changing the rule, what could I do? Not changing the rule. I'm going to plus 1 and I'm going to minus 1. I'm adding a 0. Do you guys see that? Do you guys see that? Since I'm adding a 0, so this new rule is the same as the previous rule. How does the new rule apply? Well, the new rule says the following. Okay, you give me input, output. I'm going to plus 1, I'm going to minus 1. Do these two seemingly different rules, do they produce the same output for the same input? Yes or no? Do you follow me?
Yes.
Yeah, they produce the same rule, produce the same output. But as a consequence, we're going to get a perfect square. Minus 1. So under this case, I'm going to use this rule. So all 3 rules, given the same input, I'm going to produce the same output. So the rule is not being changed. But I have different looking mathematical expressions. Do you guys see that? We have different looks. But why do we prefer this form? That's a question. Why do we prefer this letter form? Why we manipulate algebra? Because we can gain more insight, which we're going to cover. Because from this last expression, even though it's still the same rule, it just look different, I can tell the vertex. From here, I cannot tell the vertex. You guys know what I'm talking about? We will go in those details later. If you have forgotten.
Right?
Sorry?
It's the highest or lowest point?
That's right. This last one can tell you the lowest point right away, but this one doesn't. Do you guys see that? Do you see the merit of doing it? Doing that manipulation? And you're going to see more of it. You're going to see more of it. Okay? Because this part is taught in intermediate algebra. Of course, we're going to review that part of intermediate algebra. If you guys don't, I know some of you may not be following me, but that's okay. Because we're going to get there again. We're going to get there again in detail. Right now, I'm just explaining to you the usefulness of the second principle. Do you follow me? Do you guys follow me?
Yes.
Yes, Professor.
Thank you. Number 3, principle number 3. What does principle number 3 says? Principle number 3 is an if statement. Right? Principle number 3 is an if statement. If principle number 3 is an if statement, we can only use principle number 3 for if statement. Is that clear? This is what it says. If one number is the same as the other, okay, if A is the same as B, then A plus C is the same as B plus C. So if two quantities are the same to start with, and we add the same number to the two quantities respectively, the results are still the same. But most important that it is an if statement. You follow me? Can we say this is also self-evident truth? Can we say this is a self-evident truth? Yes, thank you. It looks true to me. Does it look true to you? And we're using this principle a lot to solve equations, right? Because remember, equation is a statement, is an if statement. For example, we did this one. How would you apply this? You subtract 5 on both sides, right? And you're using principle number 3. Why can we use principle number 3 here? Because this is if statement as well. So I'm talking about these at the beginning of the semester because they are super important. Throughout the semester, I will remind you over and over again. That's right, it has its conditions set, perfect observation. The principles for if statement can only be used for if statement. Very observant, Vincent. Okay, now, so you subtract 5 on both sides and blah, blah, blah. You guys know how to do that, right? Number 4. Number 4 is a little interesting because number 4 and number 3, they're not entirely parallel. Okay, it says if one number is the same as the other and you multiply the same number on both sides, but it has a little attachment here. C cannot be 0. It is an if statement, as Winston made it. It has its conditions, right? The condition is that if the two are the same. So if the two are the same, and these two are also the same, but provided C is not a 0. The question is, can we remove this condition? Could I remove this? In other words, I'm asking you, is this necessary? Winston said yes. Anybody else? No, Christopher says no. We cannot remove it. Since it's there, it must be necessary, right? But who says you cannot protest mathematical principles? Just because it's written in the book doesn't mean it's always right. Not necessarily, right? No, okay. It looks like some of you think that it should be there. Okay, now, a lot of you did not respond, but that's okay, because I'm going to explain to you. It is necessary because anything times 0 equals to 0. That's a very good comment. But then if A is the same as B, then 0 equals 0. What's wrong with that? It doesn't cause any contradiction, right? Right? Because if A and B is 0, I multiply 0 on both sides. And I'll get 0 equals 0. 0 equals 0 is true. So I'm going to make an exaggerated, but actually not exaggerated statement. If we remove this condition, if this is removed and we have this, the entire mathematics will have to be redone. If we call the current mathematics as it is, as a building, that building is going to collapse. I said I'm exaggerating, but I'm not exaggerating either.
Is it because it doesn't follow?
It doesn't follow.
So,
Doesn't
because,
follow what?
well, if A equals B, that doesn't mean that 0 equals 0. I mean, they're both could be true, but
Both are true, but they're not contradictory, right? If A is the same as B, then it doesn't affect the fact that 0 is 0, yeah?
right.
Well, how does that cause the collapse of mathematics?
Because it's a logical fallacy?
The logical what?
Is it a logical fallacy? Mathematics is built on logical principles.
That's right. That's right. But how so? How so? Okay. So I know you guys, you guys are all correct in your own way, but it doesn't seem to have convinced you that it's going to cause the collapse of mathematics. Are you convinced or not? So I'm going to show you the following work. Okay. Suppose I'm using this principle. I'm going to do some mathematics to show you. Okay. So if A is same as B, then, okay, I'm going to derive the following. Okay. That means AB is the same as A squared. Right? And A squared is going to be B squared. Do you agree?
Yes.
Right? Because A is the same as B. Then from here, I will have A squared minus AB equals 0. And A squared minus B squared equals to 0. Do you agree? Do you agree?
Yes.
Okay. Since A squared minus AB is 0, A squared minus B squared is 0. Therefore, A squared minus AB is the same as A squared minus B squared. Yes? Is that right?
Right.
Any questions? Yeah, you can see some people think, I don't think it's necessary, right? So some of us think it's not necessary to require C not equal to 0, right? Which is fine, okay? So right now, I just want you guys to follow these steps. So if this is true, and now I'm going to factor. I'm going to factor on both sides. Okay. We have a minus b, therefore I'm going to have a equals to a plus b.
Professor, missing the square of B, capital letter B.
Oh yeah, that's right. Thank you. Thank you, Varuz. Since a is the same as b, I have a equals to a plus a. Then I have a equals to a. Then I have 1 equals to 2. Yes. If you look at if you look through the steps, I want everybody to examine the steps. Okay, under the condition that a is the same as b. Tell me what's wrong. We understand 1 is not the same as 2. The conclusion is wrong. But what happened?
The conclusion isn't true only
Yeah.
in the
Shouldn't-
case of 0.
I'm sorry?
The conclusion is false only in the case of 0.
If I put a equals 0, b equals 0 in the place, there still be, I can still go with the steps, right? Because the principle I use is this one. Right? So tell me which step that caused this mistake. Which step caused that mistake? You multiply the same value by 2. Where did I multiply the same value by 2? Which step are you talking about? Where did I multiply both sides by 2? A equals 2a, and I divide both sides by a, so 1 equals 2. I didn't multiply by 2, I divide both sides by a. A is the same as b, a times b is a squared. A squared is b squared, no problem, right? Because a is the same as b. You can square both sides, you multiply both sides by a, that works, right? A squared minus ab is 0, a squared minus b squared is 0. Because both are equal to 0, therefore a squared minus ab is the same as a squared minus ab because they're both zeros, right? Then I factor both sides and I cross out a minus b and I get a equals a plus b. What's wrong? What is wrong?
If A equals B, then
A equals b is given. We are talking about the necessity of requiring C not equal to 0. Which step will we get to use that principle? If A is the same as B, A minus B is 0, right? So this
Right.
is A minus B is 0. So when I divide both sides, so from this step to the next step, we're using this principle, isn't it? The question is, can we use that principle? If we can, we're going to get 1 equals to 2. If we cannot, we're not getting 1 equals to 2. Do you guys see that? So in this step, you cannot cross out the A minus B when A minus B is 0. Do you guys follow me?
Yes, Professor. That is when we divide both sides by a minus b, division by 0.
That's right. So we must require this condition. If we don't have that condition, the entire mathematics is going to be collapsed. Why? If you can get 1 equals to 2, you're going to get 2 equals 3. If you get 2 equals 3, you can get 3 equals to 4. If you can get 3 equals to 4, you can get 5 equals to 6, and so on and so forth. Do you guys see how serious that is? If that doesn't cause the collapse of mathematics, what else could cause? Besides this situation.
So, Professor, in this case, a minus b since a and b are equal each other, a minus b is equal 0. But also, you are mentioning c cannot be equal 0. So
That's
C,
right. So if we don't explicitly require this, when you see this statement, it implies C can be 0. If C can be 0, then we will cause 1 equals to 2. If you have 1 equals to 2, we're going to have 2 equals 3, 3 equals to 4, 4 equals to 5, and so on and so forth. So in the end, you're going to get 1 equals to 2 equals 3 equals to 4 equals to 5, and so on and so forth. Do you guys follow me that?
Yes.
So let's look at how serious that mistake, right? So you're going to get 2 equals to 3, right? Because you just add 1 on both sides, right? Then you get 3 equals to 4. So what kind of chain is that? 1 equals 2, 2 is 3, 3 is 4, 4 is 5, and so on and so forth. Isn't that ridiculous? You follow me? So we must have this requirement. That's the bottom line. Yeah? You're going to see this on quiz number 1. If that condition is removed, it's not going to work. It will not be a mathematical principle. We don't have such a mathematical principle. So to conclude, okay, this is good. This is bad. You follow me? And this is the why. When we're talking about loopholes, right? Have you guys heard the word loopholes? Everybody heard about it, right? Loopholes. How do you spell this? Is that how you spell loopholes? I don't feel it's right. How do you spell loopholes?
Loopholes. There's an H.
There's an H, loopholes. I saw something was missing, right? This is the loophole, right? What is a loophole? when we make these statements, say if A is the same as B, then AC equals BC, where C cannot be 0 versus the next statement, what is a loophole?
An exception?
Exception, right? We're finding a hole in that statement because the second statement allows C can be 0. The first statement says C cannot be 0, it closed the loophole. And this latter statement opens a loophole. That loophole caused a ridiculous result. Oh my God, it's 1:34. Am I going over? What time is it? Okay. I'm sorry about that. I ran over the class.
It's okay. We didn't even catch it. We're paying attention. So
Thank you. Thank you for your patience with me. I really enjoy the class. I really enjoy meeting you all of you guys. So we're gonna end here. Principle number 4. Okay, do you guys see that? Do you guys see the point?
Yes.
So when we multiply or divide by on both sides of the if statement, the equations, we have to make sure whatever number we multiply or divide cannot be 0, because we cannot use this statement. This statement has loopholes. Okay, so I will see you guys tomorrow. Thank you for your patience.
Professor, quick question. Sorry.
No problem.
So pretty much right now, we just went over page 1 of the notes, right? Correct?
Correct.
Okay.
Correct.
Thank
And
you.
tomorrow we will continue, but I do have some homework for you, okay? I want you guys to look through the notes,
Okay.
okay? Because this is a review class. I want you guys to get to every section to assess your, whether you can do it, you cannot do it, you have any questions, get back to me. So I will have a better assessment of your standing and how I can better help you. Because I do have a plan for you according to my past experience, but if there's new questions comes up, I will be happy to address those issues.
Are we supposed to go through like the whole note package, or is there to a certain point that you want us to go to?
Just look through it to see how much you remember how to do it and how much you don't remember how to do it.
Okay, thank you.
Mhm.
Professor, question.
Mhm.
Your office hours for this class is same as the office hours for other class?
Yes, same.
Okay, thanks.
Yeah,
Professor,
thank you guys.
I had a quick
I'm so
question.
excited for the semester. Someone saying something.
Yeah, I had a quick question.
Mhm.
It's 11 a.m., not p.m., right? For class?
Yeah, 11:15 a.m.
Okay, thank you.
Thank you.
So it's 11 a.m. to 1:15 p.m., correct?
It's actually 11:15 to 1:20 today.
Okay.
And other times is Tuesday, Wednesday, Thursday is from 11:15 to 12:50.
Okay. So today, so like when I'm sorry. So Monday is support only, or is it everyday support?
We kind of mash them together.
Okay.
There's not really a clear cut.
Okay. Okay.
Yeah.
All right. It's my first
Uh-huh.
time ever taking the support. So yeah. All
Yeah,
right.
today is essentially the time for support. But I would say that we cover this material is fitting for the support.
Yeah. Yeah. No, I understand. It makes sense. All right, Professor.
Okay.
Thank you. I'll see you tomorrow. Okay.
I'll see you guys tomorrow. I'm looking forward to it. I apologize for going over.
Yeah. Don't worry about it. Thanks.
Mhm.
Thank you, Professor. See you
Thank you
tomorrow.
guys.
Bye.
Thank you, Professor.
Bye.
I had a question.
Yes.
For our quizzes, like how will they be formatted? Like, are they on Canvas and are they like multiple choice, or are they like fill in the answers, or?
You have multiple choices, fill in the blank, and written.
Oh, okay.
Yeah.
Are they on Canvas?
On Canvas, yeah. For the written quizzes, you're gonna be upload the file and to Canvas.
Oh, okay.
Yeah.
And then for our homework, well, our homework for today is just to like look through the notes and like see what we can remember and see what we recognize, right?
Correct, but I will have some, I will have some, I will have the homework as phrased. Okay, after class, I'm going to have the homework specifically stated at what I want you to study. And of course, you can always study more than that,
Mm-hmm.
okay?
Okay, thank you, Professor.
So check your homework page a few minutes after class.
Okay, thank you.
All right, thank you.
Professor Wang,
Yes.
I have a question on the syllabus.
Mhm.
For quizzes, midterm, and final, it says extra credit is available. Like
Yes.
what? I don't know if it's too early to ask, but what would that be like?
Well, suppose the quiz is suppose the quiz might be 10 points, right? I might be, you know, I might be giving you 12 points or 13 points or 14 points, something like that. Those extra points outside 10 points, those would be extra credit.
Okay.
Yeah, and this is same for midterms and final exams and the written quiz and all sorts of quizzes. But I do have to do another calculation because Canvas cannot do that for me. So that's why I'm saying the gradebook grades is an estimate of your grade. It's not the precise calculation of your grade.
Okay.
Yeah.
All right. Thank you, Professor.
No problem. Thank you. Any other questions? You bring them on.
I had a question.
Yes.
Well, just for me, just for like some additional help. You know, I'm a little older. I'm 23. I haven't been in school for like 5 years.
Oh, 23 is really old.
Oh no, but I just mean like I haven't studied or such in a while, so you know I'm a little bit more nervous. So I do feel like you know I gotta work a little harder to try to get to where I used to be. If I just go over the notes and you know I have additional stuff on the side that's supposed to be supplemental, but do you feel like with just that I'll be okay, you know, in the class, quizzes, homework? Because you know I do feel a little bit behind everybody. I'm not sure if there's any other people who feel the same, but I know for myself, you know, I haven't studied in a long time, you know, but I have been more so these last few days, weeks. I just want to know if the notes, if you feel that that's enough for me to get by. And I don't mean get by like I want to get a C, you know, obviously I want to do the best that I can, but.
Yeah, and then you have the right mentality and then you need to put in the work. And, you know, for today, of course, it's a kind of lighter day, but we're laying the foundation for the entire semester.
Of course.
Even though to many of you, this may sound very easy, but remember, we get to use these easy things to build on something, to build something that's more complicated and more interesting and more fabulous. So if you pay attention to the class and do the homework and keep up with the quizzes and so on and so forth and do the lectures, and I think you'll be fine. Okay. But make sure you get a textbook and, you know, really make sure you understand it. Yeah.
No, I mean, honestly, I feel lucky, you know, math is my stronger suit. So I'm not too worried, but I definitely don't want to, how would I say, like kind of fall behind, you know, I want to stay on top of everything. And, you know, I was able to situate some stuff to where I can focus 100% on school. I was just worried, you know, that, you know, maybe I might not have enough or remember enough to get by. But
I think by the fact that you're very concerned about your standing in class, that you probably will be doing well.
Yeah. No, I mean, like you were going over everything, and there were some certain things like when you pulled up the formula for mx plus b, you know, it's definitely there. I've retained some of, you know, what I learned back in high school, but it definitely threw me for a loop a little bit. I was like I should remember that. And I hopefully it doesn't come up because I can't exactly remember how to apply it to certain questions and stuff, you know. But you know, I'm trying to study and catch up. That's that way I can hold my own with everybody else.
Yes, I think you're probably not alone. That's why this class is combined with a support class.
Yeah. And
some of the things I didn't go in details today because today is more of an overview. And we will get to those points, and I think you'll be fine.
Okay, that's not a problem. You know, I'll just keep doing what I'm doing, and you know,
Yeah,
if I have any questions, I'll definitely let you know.
Yes, please. If there's anything I can help you, I'll be happy to know. And, you know, just keep at it.
Well, I appreciate it.
Of course.
Thank you.
Thank you.